Hi. This is an instructional video on how to use e-Braille tails to convert scanned Braille image files, in JPEG image format, into rich text format, or RTF, documents and Portable Embosser Format, or PEF, digital Braille files. RTF documents are like text files, but with added formatting information, such as text alignment, paragraphs, bold and italics. Simply double-click on the RTF file in order to open it with your word processor. The PEF file can in turn be used to print out copies of your work on a Braille embosser, or to read them electronically using a refreshable Braille display. When typing text on the Perkins Brailler, unless a space is included at the end of a line or at the beginning of the next line, the last word on the line will be merged with the first characters on the next one, up to the next space. As such, the line continuation without space Braille symbol is not required and should be avoided, as it could be confused with other Braille characters, such as initial letter contractions. However, line continuations with a space can be used without problem in this app. In this application, a space needs to be included after any RTF command, even though the RTF specifications state that it is an optional space. The reason for this is that when the code is transposing the Braille into printed English, it often needs to determine if any given Braille character stands alone. A Braille character that stands alone means that it is flanked by characters such as empty Braille cells, or dashes, but not by a Braille character mapping to a letter or number, such that can be found at the end of every RTF command. In other words, you must include a space after any RTF commands. Here is an example. This requirement, \strike, strikes, \strike 0, me as being important. Notice how empty Braille cells were included after the Braille versions of the RTF commands in the web browser. Importantly, the pages must be scanned with the left margin placed on the flatbed scanner in such a way that the shadows produced by the scanner light will face away from the left margin. The shadows will face the right margin of the page, when the page is viewed in landscape mode. This is because the non-white pixels actually result from the presence of shadows, the orientation of which plays a major role in image segmentation, determining the X and Y coordinates of the individual characters, and optical character recognition, OCR. For best results, the Braille document should be typed on white Braille paper or cardstock and scanned as grayscale images on a flatbed scanner, at a 300 dpi resolution, with the paper size setting of the scanner set to letter, 8.5 by 11 inches. The darkness settings of the scanner might also need to be adjusted to achieve an optimal Braille shadow to noise ratio. When scanning the Braille pages, some weight, such as 6-inch metal rulers, should be placed on the back of the Braille pages to prevent them from sliding on the glass of the flatbed scanner. The pages tend to move around when closing the lid, as there is very little friction keeping them in place, since their only points of contact with the glass are the embossed Braille dots. Should the page move out of line, then the segmentation results could be adversely affected. To ensure that the segmentation has proceeded adequately, the segmentation result image, scanned image overlaid with green character rectangles, for every scanned page of the Braille document should be quickly inspected. These images are generated by the code and stored in the page image files with rectangles folder, which is created automatically by the code. The left margin on the Perkins Brailler should be set at its minimal setting in order to maximize the printable space on the page and to always provide the same reference point to the code for the segmentation step. The pixel X-min, at which the code starts cropping characters on every line, needs to be entered manually in the code, as you initially calibrate the code to your own Brailler and scanner combination. In my case, the value of the variable X-min is set to 282 pixels in line 140 of the Python code e-Braille-tails.py. After running the code on a scanned Braille text image of yours, you could then open the JPEG image overlaid with green character rectangles, see figure 1 below, in a photo editing software such as GIMP, in order to locate the pixel value along the X-axis, in landscape mode, at which the segmentation should start in each line. Every brailled line should have Braille characters that when taken together contain at least 3 dots per Braille cell row in order to be properly detected. Should a line only contain characters that do not have dots in one or more of the 3 Braille cell rows, you could make up for the missing dots by using at least 2 successive full Braille cells, before or after the text, which will be interpreted by the code as a typo, and will not impact the meaningful text on the line in the final rich text format, RTF, and Portable Embosser Format, PEF, files. In addition to the RTF and PEF files, the code will generate a braille.txt file containing the OCR results before transposition to printed English, so that you could revisit the text in Braille form. Each page of this .txt file will line up with the pages written on the Perkins Brailler, and will be separated from one another by 2 carriage returns, to ensure easy navigation throughout the document. In order to submit a scanned Braille text page to the code, you will need to place the JPEG image in the OCR raw data subfolder of your working folder, which you created at step 8 of the Getting Started section. Please note that all of the file names in the OCR raw data folder must contain at least one hyphen, in order for the code to properly create subfolders in the OCR predictions folder. These subfolders will contain the RTF document, along with the .pef and .txt Braille files. The reason for this is that when you will scan a multi-page document, you will provide your scanner with a file root name, for example, mytext-, and the scanner will number them automatically, for instance, mytext-.jpg, mytext-1.jpg, mytext-2.jpg, mytext-3.jpg, and so on, and the code would then label the subfolder within the OCR predictions folder as mytext. The OCR prediction results for each page will be added in sequence to the mytext.txt file within the mytext subfolder of the OCR predictions folder. Should you ever want to repeat the OCR prediction for a set of JPEG images, it would then be important to remove the mytext subfolder before running the e-Braille-tales.py code once more, in order to avoid appending more text to the existing mytext.txt file. In order to run the e-Braille-tales.py Python script, go to your working folder in the File Explorer, and click on the folder's arrow in the Windows header. Then, simply click on Open in Terminal in order to open a windowed command line, with a correct path to your working folder. Activate your virtual environment by copying and pasting the command in step 3 of Getting Started, source, env/bin/activate. Then enter the following in the command line, Python 3, e-Braille-tales.py. The first thing that the code will do is perform segmentation, determine the X and Y coordinates of every Braille character. The segmentation results are visible in the page image files with rectangles folder, which is created automatically by the code. You might need to adjust the value of the variable xmin, at line 140 of the e-Braille-tales.py Python code, in order to initially calibrate the code to your Perkins Brailler and scanner combination. Go ahead and open the JPEG file with segmentation results, green rectangles, in a photo editing software such as GIMP. Take note of the pixel at which the Braille character starts along the x-axis, in landscape mode, and update the value at line 140 of the e-Braille-tales.py Python code. You should only need to find the pixel value of xmin, and update it in the code once, as illustrated in Figure 1. You can observe that the RTF, pef and .txt have been generated in the OCR predictions subfolder. Alternatively, it is possible to resubmit the .txt file to the e-Braille-tales.py Python code once you have made modifications to it. The Braille text will be extracted from the text file and the carriage returns that were introduced to facilitate proofreading will be automatically removed by the code, if still present. Simply place the corrected text file in the OCR raw data subfolder of your working folder and include the name of your text file when running the Python code, as follows, Python 3, e-Braille-tales.py, followed by your .txt file name, within quotes. Importantly, the file name of the .txt file shouldn't be changed, as the hyphen, which was included in its name by the Python code, is required in order to resubmit it to the Python code, similarly to what was mentioned earlier with regards to JPEG file names. When providing Python with the name of your file, and placing the text file in the OCR raw data folder, the OCR step will be circumvented and your Braille text will be converted to the RTF and pef files. You can continue this process until all mistakes have been dealt with. The following RTF commands are automatically converted into pef tags by the code and are transposed from Braille to English RTF commands in the RTF file. The Braille equivalent of the tab RTF command, \tab, will be changed to 2 successive empty Braille cells. A line break RTF command, \line, will be converted into a line break, row pef tags. New paragraph RTF commands, \par, will be mapped to a line break, row pef tags, followed by 2 successive empty Braille cells, as new paragraphs in Braille documents are typically started by 2 empty Braille cells that serve as a tab. Similarly, in the RTF document, any Braille new paragraph RTF commands, \par, will be switched to, \par \tab, to add a tab at the start of every new paragraph. The page break RTF commands, \page, are changed for a line break, followed by a page break, row and page pef tags. Finally, new section RTF commands, \sbk page, are swapped out for a line break, followed by a page and section break, row, page and section pef tags. Although I didn't demonstrate the section break here, it could be interesting to start a new chapter, for example. For an in-depth explanation of all the most common RTF commands and escapes, please consult the link in the description. These are the only RTF commands that are automatically removed from the Braille text and converted into pef tags. All other RTF commands, if present, will be carried over in Braille form into the pef file and could be removed manually afterwards. However, as Braille already encompasses typeform indicators for symbols, words and passages written in caps, italics, bold, underline or script, which is text in font size 28, as well as symbols in superscript or subscript, there should be limited need to resort to other RTF commands than those listed above. When using grade 1 or numeric indicators, these should be placed directly in front of the characters they will be affecting. The next order of priority is the capitalization indicators, followed by the other typeform indicators, bold, italics, underline, script, and finally by superscript or subscript indicators. And that's it. You're now ready to convert your Braille manuscript into digital format. If you are close to someone who is visually impaired and would like to help them find meaningful work through technology, or maybe if you are only sprucing up your Braille skills in preparation for the zombie apocalypse, LOL, then this app is for you.